Moving further, what you will see, the next lecture is about the mesh analysis or the current method for circuit analysis. This is also known as mesh analysis or loop analysis or loop method. So to solve the electrical circuit. So still now in this series of courses we have seen about the active and the passive elements. The active elements are the ones which are the current sources like the voltage here. The passive elements are like the resistance, etc. And then we saw the KCL and we saw the KVL. We also saw the parallel and the series simplification of circuits. So again, by applying the KCL and the KVL only and simplifying the circuits using the parallel and the series method, when we are solving very big circuits, it could be little bit difficult to solve it using only a KCL or a KVL. So to solve such kind of circuits in a simplified way, you can apply the mesh analysis or loop method. This is one of the methods starting from which you could go further into what is the branch current method, then the Thevenin's and the Norton's equation for solution. So looking into this circuit, what we have is a voltage source here which is a 10 volt, then there is a 5 ohm current which is a R1 resistance, then there is a 10 ohm resistance, and there is again a 10 ohm resistance. So the I1 is a current which is coming into the circuit, then there is a I2 current, and then there is I1 minus I2, which can be written as why we are writing this is that what we are doing is that we are taking a mesh or a loop. So any closed circuit, so this is a circuit which any closed path, so this is a path which is closed. So again this is a path which is closed. So what we are saying is that this path will have a current which is I1 and this path will have a current which is I2, and then we will take each we will solve this for each of the loops. So for this path we will have a equation. So to get that equation, what we will do is that we will apply the KVL, and again while applying the KVL, the minus 10 ohm we can write as this is 10 volt, we can write as this is there is a voltage rise, and then all the voltage drop across all the resistance in this path. And while you are considering this resistance, specifically this resistance, it is seen that the current I1 which you have taken for this loop will be flowing in this direction, and the current I2 will be flowing in this direction. So this is I1 and this is a I2 which will be flowing through the resistance 10 ohm. So it will become I1 minus I2 when you are going in this direction. So when you are applying the KVL there, and by doing the solution of the equation, this is the first equation which you will be getting. And again if you are traversing through the second loop, this will be the equation which you are getting by applying the KVL again to the second loop. And by simplifying the equations, you will get the equation 1 and 2, and finally what you will get is that by solving the equation you will get I2 as 0.5 ampere and I1 as 1 ampere. That's what you will get by solving the equations. So you have got I1 and I2 by solving the two equations, and again to verify those you can substitute the values in one, the equation which was first formed by the KVL on loop 1. So when you will substitute the value of I1 which you have found and I2 which you have found, you should get a 0. So we have verified whatever value for the I1 or I2 we are getting is correct by substituting it, and the final result which you have got is a 0. So our solution for this equation by applying the loop method is correct. So what we have done to apply the loop method, so again just pausing here to show you back. So again, just looking into the circuit, what we did was mesh analysis or loop analysis. So we did a loop analysis. So we this was the first loop or the first closed path for the circuit, and this was the second closed path for the circuit, and we applied KVL for the second step. Was the first step in loop analysis was finding closed path. So this circuit had two closed path, so we found two closed path. That was the first step, and to each of those closed path we assigned a current. For this closed path we assigned current I1, and this closed path we assigned current I2, and we assigned the direction of the current as uh, this way, like it is going from the voltage source and it is coming back to the voltage source. So same direction, that is the direction is clockwise. So we applied the direction of the current for I1 and I2 in the clockwise direction, and we applied it to both the loops which we found. So first we decided the closed loops which were there. We found two loops, then we for each of the loop we in the clockwise direction we assigned the current I1 and I2. So again we got a first equation of KVL. By applying the KVL on the first loop, we got a equation. Again we applied the KVL on the second loop, and we got a one more equation, and we solved both the equations. The first equation we simplified it, again the second equation we simplified it, and on simplifying the second equation, what we found was uh, we found that 2I2 equal to I1. So we substituted that in equation 1, that is 2I2 equal to I1. We substituted in the equation this equation. So by substituting that, what we got was we simplified the value of I2 as 0.5 ampere, and again we got, by substituting again in the equation which we found, that 2I2 is equal to I1. So we found the value of I2 as 0.5 ampere, and again substituting that, what we found was the value of I1. So in this way we have found the value of the current. So this kind of questions could come, and it could be asked to find the current in any of the resistance, or the value of the current in any of the resistance, etc., or even to find out the voltage sources if the current is given for a loop or a resistance and you want to find the voltage source, etc. You can use the mesh analysis or loop analysis method, and finally we verified that. So I explained it 2 times. So if you like this video, please do watch, and the next video we will see the branch current method to solve a similar kind of a problem, and again after that we will see the Thevenin's and the Norton's method, also the superposition theorem to solve the network analysis problems.